Hello friends! Today we will take the lesson of matter construction. Before we go into the lesson, I have something to show you. Look here with me. This is a large piece of iron. If you try to break it with a hammer, what will you get? Small pieces like this, of course. My question here for you. Do you think these small pieces of iron are the smallest thing you can get from the iron piece? Actually, no. If you try to break it more and more, it's also not the smallest, because the smallest thing of the iron piece is something that you cannot see with your eyes. Something called molecule. Molecule. So again, the large piece of any matter, iron, aluminum, sulfur, any matter, is made up of very small thing called molecule, which cannot be seen with your eyes. So now let us define the molecule. What's meant by molecule? Let's read the definition. Molecule is the building unit of matter. Building unit, it means that matter is made up of molecule that can exist freely, which means I can see each molecule alone. Of course, with special devices, not with my eyes. So again, each molecule can be found alone and has the properties of matter. This is very important. It means that if I have something red or something green, so this color is due to the molecule. If I have something with good smell, something with bad smell, this is also because of the molecule. So molecule has the properties of matter. Let's read the definition again. Molecule, the building unit of matter that can exist freely and has the properties of matter. Okay, but I still don't believe you. I still don't believe that the matter is made up of something very small like this molecule. I don't see it. But now I will show you an experiment that you can feel it. Look here. I will get a cup of perfume, or you would break any beaker and put some perfume in this beaker, like to be 100 grams. And then you will leave it for a period of time, some hours or maybe a day, and then let's back again to see what is the mass of the perfume. Actually, it becomes 95 grams. Oh my God, is it magic? Where is the 5 grams? Where did they go? Actually, they spread over the room in the air. But did you see it? Did you see the perfume going in the air? Of course, no. Why? Because what goes in the air was very small that you cannot see with your eyes. And this, which goes and you couldn't see, is actually the molecule. You didn't see, but you feel it when you see the mass becomes 95 instead of 100. So now I proved for you that the matter is made up of something we cannot see, which is called molecule. Here I can tell you that in this lesson we are going to study 3 points. Number 1, properties of molecule. Number 2, temperature and matter state. Number 3, kinds of molecule. In order to know the first one, we have to try to answer this question. Do you think the molecules can move or not? Let's see a video to understand. Look here with me. In this video, we have 2 cups of water. Whatever it's hot or cold, but I have 2 cups of water. And I will add here a substance, some matter. What is this matter? I will try to put it. Because I want to see this matter, which is, I know now it's made up of molecule. I want to see, will the molecule move or not? Once I put the substance, it will stop as it is, or it will move through water. So let's see. Actually, I see whatever it's hot or cold water, I see the substance or this matter is moving everywhere. The molecules spreads over the water, which means, yes, it's true. Molecules can move. So this is the first property. Permanganate particles, which are the substance that he used here, it is permanganate or potassium permanganate, spread over the water, which means that's right, the matter are in a continuous motion. So here I said the first property. The molecules of matter are in a continuous motion. Any molecules? Yes, any molecules. So I have to ask you a question. We already did now a molecule of some liquid matter. But what if I have gas matter, like perfume? Do you think the molecules of this gas also in a continuous motion? Of course, yes. If someone sprayed some spray or some perfume and you was at the end of the room, like you are in the other side of the room, will you smell this perfume or not? Yes, you will. Because the perfume molecule will spread over the room until it reaches to you. That's why you smell it and say, oh, you have a good smell. Because the molecules goes and move and then reaches to you. So yes, gas particles or gas molecules are in a continuous motion. Last one. What about solid, like this rock? The molecules here are in continuous motion. Do you see it's moving anywhere? I will answer no. But actually, yes. It is also in continuous motion. How is that, teacher? Solid? Rocks cannot move. Yes, rocks cannot move in front of your eyes. But actually, it is moving like making a vibration in its place. All the molecules are moving like they are making vibration in their place. So, they are moving in their place, and that's why I say yes. Also, solid is in a continuous motion. Even if it's not go from place to another, but it's moving in same position. Finally, we can say that solid, liquid, or gas, all of them are in continuous motion, but the solid is limited. The liquid is more free than solid, of course, and the gas is completely free. It can go everywhere, anytime, and for the long distance. This is all about the first property. Second property. To understand the second property, I have to ask you a question. Suppose that these green particles are the molecules of some matter. So this is molecule, 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 and this is molecule, molecule. Do you think the matter or the molecules of the matter looks like this or looks like this? I mean, do you think the molecules are very close to each other, like there is no space between them? Or they have a space between them? What do you think? Actually, let's see an experiment to understand if they have or not. In this video, we have two liquids, red and green. And as you can see here in this tube, we have two marks. This is mark of 50, this is another mark of 100. So, by logic, if I put 50 of this red matter and 50 of this red matter, so finally, how much I have to get here? Of course, 100 milli, right? Let's see, will I really get 100 or not? I supposed to have 100. I will see. He first put the green until the point of 50. Then he put the red, and he supposed that after he put 50, they will be 100. Look here, he put 50 and 50, and then he will try to check them together. Okay, now let's see how much exactly are them when they are together. Oh my God, look here with me. Is it in the black line exactly? Is it 100 exactly? I see no, it's here, which means it is less than 100. It's smaller than 100. So what happened? Why it is not 100? Even I put 50 and 50. Actually, that's because there is space between the molecule. Like this, if I have 1, 2, and 3 molecule, and you try to put a molecule to them. When you try to put the molecule, you suppose that it will stop here. But actually no. First, before it stops here, it will go here in the space between them, in the space between them, in the space between them, and then stop here. That's why they are less than 100 milli, because it goes into the space that's found between the molecule. So let's say now, this is our experiment. First, if we have 300 milli of water and 200 of ethyl alcohol, and we put them together, it's supposed to be 500. But actually, it is not 500, it is less. It's about 400 milli. What happened? The alcohol molecules are distributed or go in the intermolecular space, in the space that found between water molecules. So, yes, there are spaces between the molecules of the matter, which is called intermolecular space. Inter means between. Molecular, it comes from molecule. So here I have a space between molecule, which means intermolecular space. This is the second property of the molecules. There are intermolecular spaces among or between the molecules of matter. There is a definition of the intermolecular space. Let's read it together. The spaces that are found among the molecules of matter. So the definition is like the name. Nothing is different. I see it's very easy. Intermolecular space is the space between molecules. That's everything. Third property. To see the third property, although we have to answer some question. For this solid object, this metal piece, it's very hard to cut it or to separate it. But what about some water? Can you separate it? Of course, very easy. I can get some of water and leave some of it, like I cut it. I can separate it. So for this liquid, yes, it is very easy. Why? Why in the solid I couldn't, but in the liquid I could very easy? Actually, because as you can see here, these are solid molecules. They are very close from each other, like they're touching each other. So the attraction force between them is very strong. But look in the liquid. No, they are away from each other. Not so close like solid, not touching each other even. That's why the attraction force between them is very weak. They don't attract each other very well like solid. They are more free. That's why you can separate or you can cut it, let's say cut it from each other. So again, I want to say here that there are intermolecular, but not space, force. There are also intermolecular force between molecules. If this force was very strong, like in the solid, I will never cut it. If this force was weak, like in liquid, then it is very easy to get some and leave some. This is the third property of matter. So let me show you here, because of this intermolecular force, what happened for the matter. If I have something liquid like water, now look, this water takes the shape of the bottle. Do you think this water can take another shape, not the shape of the bottle like this? Very easy. If I put this water in a cup, then it takes the shape of the cup. So water or liquid can change its shape very easy. This is the first point. It's indefinite shape. Indefinite means it's able or it can change. But what about gas? Of course, it's easy to have different shapes. Look here, like the balloon. It's very common. Heart balloon, circle balloon, star balloon, whatever the shape, you put air and it takes the shape of what you put on. That's why, yes, gas, like liquid, it has indefinite shape, which also mean what again? Can change. The shape of gas can change. What about solid? Let's see. I have here a piece of iron cube. If I put this iron cube in the beaker, will it take the shape of beaker like what happened in the liquid? Of course no. Still, as it is, cube of food. So that solid has definite shape. Definite shape means I cannot change my shape. So again, liquid and gas can change their shape, but solid never change its shape. Here I finished the first point in the lesson. Next time, inshallah, we will continue the second and third points in the same video. If you have any question, leave it to me in the comment. Thank you so much. Bye bye.